Hello everyone, welcome to my poster. My name is Zhang. I'm a master's student in the Department of Civil and Environmental Engineering here at University of Nebraska-Lincoln. Today my poster topic is energy dissipation optimization for circular culverts. Let's go to the introduction section. What is a highway culvert? A highway culvert is a conduit that allows water to flow through the highway embankment. In this diagram below, you can see this is a highway culvert. This one in particular is called a broken back culvert because of this inclined section. In this diagram, you can see that this top section is the highway embankment and this is the culvert. The culvert outflow can cause erosion and scour to the receiving channel and lead to negative impacts. To mitigate these impacts, energy dissipation structures need to be designed and implemented at the culvert outlets. Currently, some of the existing energy dissipation structures include riprap basins and rigid concrete structures, which require significant cost of construction, maintenance, and right-of-way. Objective. As we just mentioned, some of the current energy dissipation methods have some disadvantages, so we need to find ways to improve them. The objective of our research is to design and improve energy dissipation designs for circular culverts to mitigate downstream erosion, lessen sedimentation and blockage by debris, minimize the footprint of energy dissipation structure, and reduce cost. Tasks. In our research project, we identified 4 tasks. First, review of literature and existing infrastructure. Review literatures on energy dissipation structures. Visit and review existing culvert energy dissipation structures. We will talk more about review of literature in the next section. 2. Selection of energy dissipators. Select types of energy dissipators for testing. Our focus is on weir energy dissipators and staggered weir walls. These 2 types of dissipators have already been used by NDOT, but formal design procedures are needed. If you're wondering what is weir energy dissipator and staggered weir wall, I will be talking about them in the last section of this poster. By the way, NDOT means Nebraska Department of Transportation. 3. Model construction and testing. Build models for the selected dissipators in a laboratory. Test different geometries of each model under a range of design flows. Data analysis. Use data collected in the laboratory to develop and optimize design methodology. Incorporate the research outcome into NDOT design procedure. Since this is an ongoing project, we are not yet done with all of the tasks, but currently we are almost done with the literature review and selection of energy dissipators. We are currently working on model construction. Literature review. In the literature review, we have looked at different types of energy dissipation structures and compare their advantages and disadvantages. Here is a diagram of some of these types. A is a free hydraulic jump. Most energy dissipators use hydraulic jumps to dissipate energy, but free jumps are the simplest way in the sense that no additional appurtenances are needed to induce this hydraulic jump. Additional appurtenances are appurtenances like baffles or sills. B are baffles. Baffles are these concrete blocks you can see in a basin. Baffles are one of the most common methods for energy dissipation being used. When flow impacts the baffles, Baffles can dissipate energy in three ways. First, they can dissipate flow energy by creating friction. Second, they can redirect flow into other flow streams, dissipating additional energy. Three, the baffles can induce immediate formation of jump to dissipate energy. C is a sill. Sills are walls across a channel that force the water to go upwards and over them. Um, when the water goes up and over, hydraulic jumps can be induced. D is a drop. Drops dissipate energy by impaction, flow recirculation, and air entraining. E is a plunge basin. Plunge basins are very similar to drops, but plunge basins use a deep pool and use shear stress between the plunging jet and the water in the pool to dissipate energy. F is a counterflow mechanism. A counterflow device can change flow direction so turbulence and shear can dissipate most of the energy. In E are flip buckets. Flip buckets direct part of the flow upwards to induce a hydraulic jump. In H is a design basin. Design basins use a combination of different mechanisms that we mentioned above. In summary, there are 4 ways to reduce flow energy. The first one is to impinge the incoming flow on a solid surface. The second one is to cause one part of the flow to travel in a different direction than another part of the flow to induce shear. The third method is to entrain air. The fourth method is to induce the formation of hydraulic jumps. Model construction. To run experiments to determine the efficiency of our selected energy dissipators, we will have to build a test system first. The test system consists of 3 parts: the head tank, the model pipe, and the test basin. The head tank has a head gate on it to regulate the incoming flow depth. The model pipe represents the broken back culvert, and the test basin is where we will place our model energy dissipators in. And here are 2 pictures of the construction progress we took last week. Methodology. The experimental model design relies on fruit similarity. Fruit similarity means that fruit number are constrained to be the same in the model and the prototype. Fruit-based similitude prevails when viscous forces, surface tension forces, and compressibility forces are all negligible compared to gravitational forces. Based on fruit similitude, we can come up with a chart of different parameter ratios. From what I mentioned before, we have 2 different energy dissipators that we selected for testing. The first one is a Weir energy dissipator. This is the top view of the Weir energy dissipator, and we have a uniform Weir wall across the whole basin. Note that we have 3 weep holes on the wall to allow water to drain. So when there isn't enough incoming flow, the weep holes will prevent the water from ponding here. The second one is staggered Weir walls energy dissipator. Unlike the Weir energy dissipator that has a uniform wall across the whole basin, we have 3 different segments of the Weir walls. Yeah, these are the 2 types of energy dissipators that we'll be testing in our test system. As for results, we don't have any results yet because this is an ongoing project. But hopefully we'll get some results and conclusions soon. Thanks for watching.